Welcome to the course CS213 Object-Oriented Programming of the Cohort University of Science and Technology. This is lecture 7 of the course, and we will be discussing some additional topics and classes and objects. We will have a deeper look at the classes and objects. We will build on the concepts that we learned in the last couple of lectures, and we'll look at some of the topics that are like class variables and methods that we can cover in our last lecture. We will also look at constructor overloading, and we will look at a case study from the book, that is the time class and the time2 class that uses the constructor overloading to initialize objects with different number of variables. The recommended reading for this course is Java How to Program Early Objects version of the Detail and Detail series. And these concepts can be covered in chapter 3 and 8 of the book. You can also follow the Java tutorials that are available online. These are the official documentation that are available online on the topics that we are covering in this lecture. So a class variable is that, for example, if you want to specify a class variable or a class method by using the static keyword in the members declaration. As you can see over here, that a variable that is declared as static in a class is called a class variable, and the reason for that is we can use this variable now without creating an object for this class, and the value of this variable will remain the same for all the objects of this class, as was the case in our previous examples, that for the instance variables the value of the variable is different for each object, that is specific to each object, but for a static variable the value of the variable will remain the same for all the objects. For example, this variable x is initialized to 10 and it is a static variable, and even if we create two objects for this class, a1 and a2, the value of x will remain the same for both of these variables. And we can also see that we can access the static variable that is declared as public over here. We can access that variable with the name of the class without declaring an object for the class. This was something that we weren't able to do with our instance variables. We needed to declare objects for the classes to be able to declare the public methods or the public variables in our class. A static variable represents class-wide information. All objects of the class share the same piece of data. For instance variable, the value of the variable changes for each object, but for a static variable, a variable that is declared as static in the class, the value of the variable will remain the same for all the objects, as we can see over here. Class variables are statically allocated, so they are shared by an entire class of objects. The runtime system allocates class variables once per class, regardless of the number of instances created of that class. So we have only one copy of the variable of the class variable. The memory is allocated when the class is created. Static storage is allocated when the class is loaded. So as soon as we load the class, the static variable is assigned the storage and it is loaded. And as it's repeated again that all the instances share the same copy of the class variables. In simple terms, it means that the value of a static variable remains the same for all of our objects. Some methods do work but don't need an object. Use the class name instead of an object name to invoke. And these are the methods that we can invoke without creating an object for the class with the name of the class. So for example, round is a static method in the math class. We can call that method without declaring an object of the math class wherever we need the round method. Similarly, parseInt is a static method in the integer class. This is a method that converts a string into an integer if it is compatible. And we can call this method anywhere wherever we need it with the name of the class without declaring an object of the integer class. These methods are called class methods, and these are declared as static, as we can see over here. So a static method is called a class method, and it can be called with the name of the class without declaring an object for that class. So we declare class methods with the static modifier. Class methods cannot access instance variables. We need to remember that we cannot access our instance variables in a static method. Class methods are handled by the class object. They can be called even if there are no instances of this class. As we can see over here that we can call the static method without declaring an object for the class directly by the name of the class, and these are some of the examples that are given to us that we can use a static method or call a static method with the name of the class without declaring an object for the class. The things that we need to remember about the class variables and the class methods are that a static method can call other static methods of the same class directly, that is using the method name by itself, and can manipulate static variables in the same class directly. So we can directly use the static variables within the static methods, and we can also call static methods and other static methods of the same class. Java does not allow a static method to directly access instance variables and instance methods of the same class. We need to remember this point that we cannot access an instance variable, that is the variable that belongs to an object that is not declared as a static in a class. A static method cannot access that variable directly. It is because a static method can be called even when no objects of the class have been instantiated. That is, that this reference cannot be used in a static method. The logic behind the inability of a static method to access a non-static variable or instance variable in the class is that we can call the static methods with the class name without creating an object, and that means that we can call the static method before we have created an object for that class, and that is why we cannot possibly have a value for the instance variable of an object that has not been created yet, and we cannot use that variable in a static method. Instance methods, on the other hand, can access all fields, that is, it can access the static variables and instance variables, and it can access all the methods of the class, that is, the static methods and the non-static methods are the instance methods of the class as well. Many objects of a class, each with its own copies of instance variables, may exist at the same time. as we have seen previously, that we can create as many objects of a class as we need with its own values for the instance variables. Declaring instance variables private is known as data hiding or information hiding. We have seen that sometimes we need to declare our variables as private so that we do not directly access those variables or directly change the values for those variables. That is why we would prefer to declare those variables as private, and if we need to access those variables, we can access them through the public methods that are the accessor and mutator methods, or in other words, the setter and getter methods that we used in our previous lecture. An example application of the static variable can be that if we see this example shows us if we need to count the number of objects that have been created for a class. For example, if you have a student class and you are asked to count the number of students. Now each student in a student class is an object of the student class. And if you need to count the number of objects that are created for the student class, we need a variable, the value of which remains the same for all the objects. And whenever we create an object for the class, that value is incremented. And this can only be possible that if we declare the variable as static, and whenever the object for this class is created, that means this constructor will be called whenever an object for this class is created, and the value for this count variable will be incremented. So in this example, we have the shared counter class. It has a public static int count variable and it has an int variable. The count variable is the class variable, that is, it is a static variable, that is why it is called the class variable. And the value variable is an instance variable, that is, the value of this variable will be different for each object of the shared counter class. And we have a toString method in this class, that is, when we print the object for this class, a certain output, that is the value in this value variable and the value in this count variable will be printed for that object. So what is the expected output of this class is that we have created 3 objects for this class. The first object passes a value 10 to the variable, that is value instance variable in the class, and in the constructor the value that has been passed will be assigned to the value variable, that is the instance variable of this class, that is differentiated using this keyword, as we can see over here. So this value variable is the local variable of the constructor, and this value variable is the instance variable of the shared counter class. And we can differentiate the variables with the same name using this keyword. So this keyword will be referring to the instance variable, and the one without this keyword is referring to the local variable of the shared counter constructor. So the value 10 is passed by the first object, and when we print this object, what we expect that the value of this variable will be 10, and the value of the count variable will be 1, it should be 1. And when we create the second object for this class and we print that object, what should the value for the value variable should be 100, because 100 is being passed to the constructor of that class. And since it is a new object, so it will have a new value for the instance variable. But what should happen is that the count increment should add 1 to the previous value in the count variable. So since we have created a second object, that is why the value of the count variable should be 2. And same should be the case for the third object. As we can see over here, initially the count is 0, and when we create one object for this class, the count is incremented to 1, and we pass 10, and that is assigned to the instance variable value over here. When we create the second object for this class, the count is incremented to 2. That means that we can read the previous value of the count, that was 1, for after we created our first object, and we can read the same value and increment that using the second object. That is, we have called the constructor for the second object, and we were able to read the previous value and increment that. As against this one, we have a completely new value for the instance variable of the class, but we were able to increment the static variable or the class variable of the same class. And similarly, when we create the third constructor, the value of the instance variable is changed, but we were able to access the value that was stored in the count variable, and we were able to increment that. And if you are asked to, let's say we have an employee class, and if you are asked to do the same thing to count the number of employees that you could have, then how would you do that? So what you need to do is you need to add a static variable to maintain a count of the number of employee objects in the memory, and you need to decide that if you need to declare it as public or private. You need to write it over here. You need to complete the constructor, and what the constructor should do is it should assign the first name and the last name to the instance variables, and we need to add you need to add a static method get count, so that we can retrieve the count variable from the employee class. Now, why do we need to declare it as static? Because in our previous slide we discussed that we can access a static method without declaring an object for the class, and we would want to get the count of our objects at any time, at any place, even if we do not want to use an object to get the count of our variable, a count variable. So in this case, if we look at the variables that we have created for the employee class, ideally we should get an output of 2. As we can see over here that we have created 2 objects for the employee class, and we are able to call the getCount method of the employee class with the name of the class, and it should return the value 2 to us because we have created 2 objects for this class. Similarly, this is an example exercise of constructors, and this point class or MyPoint class is supposed to have 2 constructors. This one is without any arguments, and this one takes 2 arguments, or it has 2 parameters, so that you can initialize an object by passing two arguments, or you should be able to initialize an object without passing any arguments. So you need to complete this constructor, the code for these constructors. The constructor are supposed to initialize the instance variables to the values that are being passed as arguments to these constructors. We'll discuss constructor overloading in the next part of this lecture as well, but if you can try to complete this code before you start with the next part, that will give you a better idea of how constructor overloading can be used in object-oriented programming. So you need to complete the constructors in this exercise example. And this is the output that you should get by printing the two objects. So the first object is getting you 0, 10 and 20, then second object is getting you 0, 0. So you can use this keyword here by passing 0, 0 to this constructor, and this would give you this object. Maybe you can try it and see what the output you can get with this code. Similarly, consider the same class and try declaring the constructor as private, and you should see what happens with the code. For example, we have this employee class and we want to use the static variable to count the number of employees that we have maybe in our organization. So we declare the class public class employee, as we have been doing so far. We have class declaration, then we have the body of the class, and it is supposed to have the variables, the instance variables, a constructor, and the setter getter methods. Or here we will be using the instance variables and the constructor alone. So we declare the variables, and I declare the variables as private. Initially I just have the first name of my employee and the last name for my employee, and I want to have a count variable that I can use to count the number of employee objects. So I have declared these three variables. You can see that I have declared the static variable as private. Since I do not want it to be directly accessed from outside of the class, I will be declaring a static method to access this variable. Let's declare the constructor for this class. That will be, as we understand, then that of the same name as our class name, and we will be using this constructor to initialize our instance variable. So I have two instance variables. One is the first name, and I want to get the values for my instance variables in this constructor. String last name and I will simply initialize my instance variables with the values that I am getting at the time of object declaration. And what I am doing over here is, as was asked in the exercise that I should increment the count variable each time I declare an object for this class. And I want to have a static method that I can call at any point to return the value of the count variable. So it is asking me that the method should be able to return an integer type variable. So I declared the method as void, and we saw that the compiler wasn't happy with it. So the method needs to declare an integer, because the count is an integer and I'm returning a value from it, so I need to provide the data type of the value that I'm returning from this method. Additionally, I will add toString method that I used in our previous lecture, and as we can see that it is a built-in method and it is used to return the output of our object in the form of a string. So again, as we can see that we need to return something from this method, and unless I provide that return value, the compiler will keep complaining. We can set the format of our output using the toString method, and I just want to print the first name of my employee, and at this position it should be %s. Maybe in the next line you can do this within the same line. And close this window. You can do it within the same line as well. All I just want to do is print the details of my employee. And that is almost it. As we talked about the static variables in the static method, we said that we cannot access our instance variables in a static method. Just for the sake of understanding, if I try to access the instance variable in my, as you can see that I'm not even able to access my instance variable in my static method. If we look at the error, cannot make a static reference to the non-static field first name. Since the first name is non-static, it is my instance variable, and we said that we cannot access our instance variables in our static methods. That is why I'm not able to access this variable over here. I cannot even use this keyword. If I try to use this keyword over here, you can see that I'm not able to use this keyword here. Cannot use this in a static context. So since I'm using an IDE, the compiler is helping me over here, but you need to be careful when you're writing your programs that we cannot access our static variable and our instance variables and our static methods. But I can access my static variable in a non-static method, as you can see over here. As you can see over here that I'm able to access, and if I want to display the count, maybe I would use the %d for it, and I would want to go to the next line. Now we are going to write a test class that will be using to create objects for this class. So we have a test class over here, and we should add the main method, and inside the main method we'll be declaring objects for our employee class. And the syntax for that is name of the class, name of the object, followed by an equal symbol, followed by the new keyword, and the constructor call. Now our constructor is expecting two arguments in the form of string. I will be providing those two arguments to us, the constructor, so that it initializes my instance variables with these values. I have created one object for the employee class, and let's try to print the employee object and look at the output that we get. So I can get the name, first name, the last name, and the count exactly the way I have formatted this in the toString method. And if I create another object for this class, maybe with some other name, and if I print this one now, and we should be able to see the number of objects that we have for this class. If I change the statement a little, it might give us a better idea. So now we can see that the number of objects for this class are being displayed. If I declare the second object after I have printed the first object, now we should be able to see different outcome. So when I have created for the when I printed the object after creating the first object. It is giving me the number of objects is 1, and then when I call the constructor again over here by creating the second object, then total number of objects is 2. We can also call the static method of the class by just directly using the name of the class. So it will give me the total number of objects. So if I declare a third object over here, and maybe if I do not print this object, and if I call this get count method using the employee class, you can see that the total number of objects for this class is 3, and we can display that by directly calling the get count method of the employee class by using the name of the class. If I create another object for this class, at any point I should be able to get the total number of objects for this class by calling the get count method, that is the static method. As you can see over here, it's a static method. I am able to call this method directly using the name of the class, and we cannot do that with the other methods. We can print the details of the employee by either calling the toString method or even just without calling this toString method. It won't make any difference to the output or the format of this object. So this is an optional. If you want to be clear what method is that you are calling using this object, so you can call the toString method, or you can just simply print the object and it will give you the same output. As you can see over here. So this was an example of the static variable and the static method. We might be encountering the static variable in our future lectures as well.